Aggressively annoying.
Get mean, yeah. You don't want to go over. It's like going over your minutes, but Kay's got extra, so.
The
Last
same or
semester.
some pressure?
So for this first one, isobars connect locations of same pressure. Same pressure. And then wind, of course, we've talked a lot about that. Wind is created as air is moving from a high to a low pressure. And there's my H2L. And there's my little green dots are my wind. Or excuse me, they're not wind. My little green dots are my air. So it's like high pressure, low pressure, and it goes.
So it says air relocating from high to low?
Uh-huh. And so, like, this is just, but you can't read my writing.
It's okay.
And then the pressure gradient force I've kind of done in the same direction as the air is moving, i.e. the wind is moving. And pressure gradient force then is there. And then the next one, the fourth one, remember like on a weather map, if you see them close together, we call that a steep pressure gradient force and they'll create fast wind. And then if you see them spread apart, that's a weak pressure gradient force and you'll get slow wind. That's at the top there.
Okay, I see that one.
Good.
Okay, so steep is a weak pressure gradient force.
No, steep is a strong pressure gradient force.
That's easy, steep and strong,
Mhm.
two S words, ST words.
Okay, so the Coriolis Force.
The Coriolis Force, it is created because the Earth is spinning on its axis. So kind of over here on the right, I put the CF stands for Coriolis Force. So it's created by Earth's rotation. It deflects air to the R right in the northern hemisphere. And the Coriolis Force deflects air to the left if you're in the southern hemisphere. And then the Coriolis Force is strongest at the poles and weakest at the equator.
Okay. I can read that right.
What did you say about the equator?
It's weakest at the
Weakest.
equator. And then friction, most people kind of have a sense for what friction is, but it's created by roughness, is what I wrote. Friction is created by roughness. For example, the Earth's surface creates a friction and it works opposite direction as the motion of the wind.
So the force of friction slows the wind.
Yep.
And smooth surfaces.
What's the word after
Yeah,
opposite?
don't. Smooth surfaces, the wind will go faster on smooth surfaces. Yep.
Is that within?
Which word?
After opposite?
Motion.
Motion?
Yep.
Okay. Okay.
And then we talked about gradient wind and geostrophic wind. Gradient wind didn't make it, but geostrophic is that upper level wind. Winds blowing relatively straight between isobars. Geostrophic wind. And these would be isobars. They can be a little wavy. You know, we talk about Rossby waves, but they're pretty much straight from west to east at upper elevations. And they kind of go with lines of latitude. And then the next one, if somebody says they have a westerly wind, okay, oh, sorry, I got skipped. Oh, goodness. Anticyclonic and cyclonic movement. So what I did here, kind of at the bottom, was I put H and L for H is anticyclone, L is cyclone. And then we talked about different things about them. For high, air will be leaving the center at the Earth's surface, and it will be going clockwise around a high, and you'll have generally clear skies. For a low, air will be coming into the center, air will be moving counterclockwise, and you'll generally have cloudy skies because of that converging here.
I remember those by a high pressure. It's an anti. There's an I and anti.
Oh, okay. I
And
like it.
with the low, I can't remember what word I used, but I have a word association because that works real well for me.
That's cool. Then wind direction. If somebody says it's a westerly wind, that means it's coming from the west. So wind is named for the direction it's coming from.
Right.
Yep. And then you guys had a homework, and here's my butch of a windrose. A windrose is that icon that has different lengths, and the longer the length, that means that the more the prevailing wind is coming from that direction.
Are we going to need to draw one of those on the exam?
No,
Okay.
but just know what it is.
Know what it is. Yeah, that one
And then the Bayes-Ballott's law is a little kind of strange, I think, kind of nitpicky. But the Bayes-Ballott's law, you put the wind at your back, so you're looking the direction that the wind is going to, the wind at your back, and it's all about L. So if you put out your left hand, that will be your low. And so that means if you put out your right hand, that will be your high. And Bayes-Ballott's law works best at upper elevations. Oh, the computer came up, finally. So an arrow vane is a way to give both wind direction and wind speed. It's got a fin on it that helps swing it around to show the direction the wind is going. And it's got a little propeller thing that gives wind speed.
direction and speed. Got it.
Okay, on to chapter 7. Santa Ana winds. Ask Dirk. So we got a couple winds associated with kind of the Rockies area, Sierra Nevada, I don't know.
Yes, definitely the Sierra Nevada.
Okay, good. So these would be on the ocean side of those mountains. And it's a high pressure that drives air down. And as it goes down, it contracts and gets warmer. And these can aggravate forest fires. And then the Chinook winds are on the other side of the mountains.
Why are there apostrophes there?
Those little apostrophes mean like you bring down, so like these words are all the same up till Rockies. So Chinook winds goes warm, dry, downslope Rockies, and then it says east side instead of, so that's where it differs between Santa Ana and Chinook. But they both have a high pressure and they're forcing it down. Have you ever seen those little things to say, just bring down what the same word was above it? Nope.
So it just means warm, dry, downslope until we get to Rockies. It says east side.
Yep.
Yep.
Okay.
You got it.
You got it.
All right.
And then the next one I brought in a figure. So this is the one I kind of teased, put under your pillow. So actually the several terms, beginning with features of global winds, all the way through semi-permanent highs and lows. This all comes from the same figure from your textbook. So I would know those. And I said I wasn't going to include a figure. I'm going to include a figure kind of like this, just because I think it's good.
Like fill in the blank, like for Hadley,
Yep.
for the polar front. So kind of how we did on our homework assignment.
It's very similar. It won't
Are you
be
going to have the figure on?
right. I decided to go ahead and do
so
that.
I don't have to draw it.
No, not this.
Oh,
That's a good
yay.
idea, though. I'll have to do that because I tried to switch it up. Next year.
You didn't hear me
Yeah,
say that.
yeah, next year.
Yeah. So
That
Payday
one I know.
said, so
I know where the Hadley is, and the Faro, and the subpolar, and the polar.
Good. And then remember you
I
said
feel like-
the polar front. And
Yeah, the best way to remember Hadley is it's more in the middle, and Ferrell is right on the outer, and then
yeah.
then what's after Ferrell on the bottom?
Polar. It's kind of hiding here.
Why wouldn't it be anti-polar?
Annotated. Don't blame me. That's a figure call.
Because
But
that's Antarctica.
right. Yeah. There's 3 cells down here and 3 cells up there.
Okay, so it's basically the same thing.
Mm-hmm.
You should have a question about that.
You must never reveal this to anyone, especially my husband. We did a trivia night. The question was, there were actually 3 questions related to weather, and I knew the answers. And they all
Nobody
told me I was
listens.
wrong,
Well, there you go.
but you didn't hear me
That's
say
kind of the
that.
funnest. Doldrums, don't forget doldrums. Where are doldrums?
Doldrums
I'm
are around the equator,
Mm-hmm. Yep.
and they are winds that are very slow.
Mm-hmm. Yep.
So if you're in a sailboat, you're not going anywhere.
That's right. You're sitting.
Okay, so winds around the equator.
Yeah. So it's like the intertropical convergence zone. Yep.
Oh, the ITCZ.
Mm-hmm.
Okay, so winds around the equator that what?
Like then Kay said that they are very light, not very strong.
If you were in a sailboat, you would be moving extremely slowly, if at all.
You'd be bumming.
And that's the visual that I have in my head.
Doldrums. Actually, sometimes I'd like to be in a boat that's not moving very fast.
Is that a doldrum on the polar front?
Nope. On the polar front, that is
The white.
The polar front, that is the polar front.
So it's not a doldrum?
Nope. Mm-mm.
So they're only around the equator?
Right.
It's only.
Okay, monsoons. That actually is a location that seasonally, it varies by getting a lot of rain in the warm season and not getting much rain in the cold season.
Indonesia has one.
Right. So winds that are seasonally reverse direction, creating cold, dry, and warm, wet seasons. And then the polar front, you already kind of told me where the polar front is up there. It's between the Ferrol and the polar cells. And then what creates ocean currents? The movement of the water is from the movement of the air above it. Yep. So I just put prevailing winds.
You put between Ferrol and polar.
Mm-hmm.
Alls?
Cells.
Cells.
Yep.
Sorry.
And upwelling makes fishies happy and makes fishermen happy.
Yes.
Mm-hmm. So upwelling is usually along the west coast of continents, but it's bringing up cold water and nutrient-rich water from down below.
Now, what causes the upwelling?
Yeah, I didn't emphasize that much this semester,
Okay.
but it has to do with water. You figure this is our upwelling. Really, I've only heard it kind of associated with the west coast of continents. So we have upwelling here up along California and upwelling here along Peru. And in both cases, you have that that high that's bringing actually water up from the poles and down from the poles here. So that water actually kind of gets going and it creates kind of a counter current that sucks up and deposits up above.
Okay.
So it has to do with counterclockwise.
So in a way, it's almost like
Clockwise
a
in the northern
sinkhole in the
hemisphere.
water that's
Yeah. Mm-hmm.
okay.
Yeah, it's kind of a.
So it's cold water coming up from, what's the word between?
Coming up from ocean deep.
Oh, from ocean deep.
Yep. Sounds poetic. And then here's where kind of you said, well, what causes it? And I said it needs a strong current. So that's why, remember El Nino, and I have to apologize, I don't have any questions about El Nino or La Nina. I don't know what I was
mad
thinking.
at you now.
I am too. I'm like, what the heck? I just made a whole test without it. But
'Cause I know El Nino.
You can make it
I live
extra
in
credit.
California.
you have great ideas. El Nino is where the trade winds peter out or reverse
Yep.
themselves.
And then La Nina is when we have hurricane season. El Nino is when we have a bad tornado season.
Okay.
That's
I always have to look them up because I always forget.
That's how I remember it.
So then this one is kind of related to what we were just talking about. Why do the west coast of continents generally have cold ocean currents? And this was that question number 9 for this chapter where I had to go and say I would take either because of upwelling or because they're high. They're high, like if you take here by California, our high is just going to force clockwise and it's going to bring pole water down. Okay, and actually if you go in the southern hemisphere, it's going counterclockwise, so it also brings pole water down, or up from the pole.
So the high pressure is
It's
essentially pressing down on the water.
It's
and
basically like
bringing
she
the
said.
cold water up,
it's a
Well,
or is it?
it's the movement. The high is
The movement.
clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. So you figure you have a high in the northern Pacific and the southern Pacific. So it's bringing, from the North Pole for us and from the South Pole for them. So that's how I would answer that question. But kind of, I think what you were talking was upwelling. Were you talking about upwelling?
Yeah, I think
Okay.
I had it confused
Yeah.
with the ocean currents.
And actually, upwelling is a good answer too for this.
Yeah, that's what I'm looking
Okay.
Upwelling.
Like doing anything extra that I don't have to do.
So either one of those. Okay,
Wow, we're through 2 chapters already.
I know.
I know some of this stuff.
Yay! Air
I did
masses.
too. It's just chapter 7 was a little fishy because I wasn't here for some of it.
Little fishy oceans, get it? So air masses, they have the same or uniform temperature and moisture. And then I went ahead and made sure, and I don't think my test emphasizes this, but if you look horizontally, that's where it's the same. Okay, so it's like all moist or all dry or cold. But if you go up, then it's going to change because a little bit. So a source region is a place for a chunk of air to sit for a while.
Okay.
And what makes them good is they need to be big, need to be uniform, and they need to allow the air to sit there for a while. And that's why.
Uniform and allow
Horizontally the
airs to
same
dwell.
moist temperature.
So it just sits.
Mhm.
Allowed
It's like
to
do your stew,
dwell.
you just simmer it.
Yeah.
And then I went ahead with regard to maps, and there is a map, one of these 2 maps you don't know. I'm not going to tell you whether it's winter, I guess,
I
winter or
can.
summer.
I'm gonna guess. Okay. Let's see.
On the test?
The cold one, where all the blue is covering, that's winter.
Very
Summer
good.
is definitely where there's a hot spot because I feel it every summer in Oklahoma. So I know my Oklahoma.
You got it. You got it.
Oklahoma has meaty, we get probably 50s sometimes in the wintertime.
That'd be
We
I can handle
hardly
that.
ever get ice and snow, and when we do, it's because El Nino came. I know when it's going to be a bad winter. I didn't think this was a bad winter for us.
That's cool. Very good.
But it's going to be hard memorizing. MP is going to be your cool and humid. CA is very cold and very dry. CA is, okay, that helps.
C is for continental.
Mhm.
A is, I'm not going to look at that side. A is for Arctic. P is for polar, and T is for
Tropical.
Tropical. Glad you told me because I couldn't come up with it. So we have 2 polars, which makes sense.
Mm-hmm.
An maritime
2 tropicals.
tropical and a continental tropical. Okay. When you went over that in class, I was just so confused about those.
Yeah. See, I have the advantage of reading it and rereading it over 13 years. But yeah, it does get confusing.
Why does it do that?
Because when I'm doing it here, it doesn't think I'm doing anything over there. So. But it's better now, right, Kay? When you digest it, you're like, oh, okay, well, that makes sense.
So do you have an iPad or do you have
This is the school's iPad. Yep.
do you like it?
Full of questions. I do. But I think I could go Android if I had to.
I
I
have
just
an
switched
Android
Apple
phone.
and I like Apple.
We were going to get me a tablet because I don't know, I haven't used my laptop in your class, but it's an old one. It's, I think, like 8 or 9 years old. And it weighs about 10 pounds.
Yeah, they've gotten a lot lighter.
Mm-hmm.
But we went looking for a tablet for me, but they all have Windows 10 on them, the ones they're selling now. And Windows 10 is not stable enough. They've got a lot of privacy issues with it.
Okay.
so we wouldn't buy one, and I was so mad.
Oh, here's what I would do in that case. Best Buy does have an option of Windows 8.
I don't either, but I just don't want them snooping around in my stuff.
I
Well,
don't
mostly
blame
I
you.
don't want to learn a new system.
Yeah. Let's try that.
Well, I could show you how to do it if you wanted to learn.
So Airmass Modification, so it's kind of like after it's set there for a while and moves away from its source region, it starts to change. It kind of makes sense. The example we looked at was that the temperature of that air mass that started in Canada, and as it moved down, through Texas, it became modified. It became warm. So air mass picks up characteristics of the land. It's moving over by exchanging heat and moisture.
Okay, so then what's dry line?
So dry line is like it's like a front, and I said actually that it wasn't in chapter 8, it was really in chapter 9.
Okay.
But I went ahead and said what it is here. So a dry line is a front, and a front is two air masses. So the two air masses that are meeting in a dry line are both warm, so they're both T, tropical, but one is moist, or maritime, so we do an M, and one is dry, continental, so we do a C. So it's the CT and MT air masses that are clashing. And you told me that the CT air masses are only in the summertime.
Well, yeah. Look,
I see, I know.
there's one CT.
Yeah, but look at it's summer, you don't get your CA in the summer.
You get CP.
CP only.
But the arrows, the reason I know the difference is because of the arrows and the amount of blue arrows versus the amount of red arrows.
Yep.
Yeah, see, I'm right there in the red and orange.
You
I
are.
get plenty of summertime. I love
Where
it.
they
Oh.
come together.
Last chapter, fronts. So what a weather front is the boundary between two air masses.
Okay, I can read that one.
And then 4 types of weather fronts. So kind of have if you didn't already, I bet you already did already.
Yeah, we did
Cold,
recently.
cold front is triangles, blue triangles. Warm front is red
Soft.
semicircles.
I think cold, hard, warm, soft.
What were red circles?
Semicircles, red semicircles are a warm front. Yeah, soft, like Cassidy said. And the stationary front is alternating.
I actually had a really silly science teacher, and I always go through the mechanism. He said, cold front's mean and warm front is nice because it's mean when it's cold and it's nice when it's warm. I was like, okay. And then when you get scared, it's mean and warm, being friendly and trying to create some bad weather.
Oh,
That's
okay.
what I remember that. He
Um,
was a character. I loved him.
aw.
He was awesome.
I'm glad you had a good science teacher. So overrunning. Oh, by the way, that purple one up there, I put occluded front, and I said cold air outruns warm air.
That's basically when you get your bad stuff, right?
Yeah, cold fronts and occluded fronts. You get your bad
thought-
stuff.
For some reason, I thought it was stationary where you would get bad.
Stationary can be, and stationary really has for sure this overrunning on
Okay,
the warm.
so I have a question. In Oklahoma, would it be occluded or stationary for our
It
bad
could be
weather?
either.
It could be either. So say it's like really, really hot, and then it all of a sudden gets cool.
It still could be either.
It still could be either.
Yeah. Well, the Mid-Latitude Cyclone that we're going to look at actually has an occluded part, which is nasty, and then the cold front can also be nasty. And so overrunning is when warm air goes up and over cold air. Cloud types associated if you have a warm front coming, and this is where I remember I drew a little person over here, and I said you're going to see the cirrus clouds first, and the cirrostratus and altostratus, and then nimbostratus, which of course is raining. So kind of these are all stratus, flat clouds. So kind of see those.
Like outside right now, I think they're nimbostratus, aren't they?
If it's kind of precipitating.
It's like dark gray.
probably, I would just probably call them stratus, like they're low-level stratus clouds.
But you don't get rain out of stratus, you get them out of nimbus stratus.
That's right. Yeah, so if it's not raining, it's not nimbostratus.
But it could be raining. It felt like it was gonna rain this morning. I'm full of.
Talking about the same thing here.
Okay.
Mid-Latitude Cyclones. Okay, so I brought two figures from your textbook. This is a good mid-latitude cyclone example. We see that purple is the occluded front.
Mm-hmm.
We have cold front, warm front. And where is the nasty weather? Well, it could be here with the occluded part, and it could also be here. Probably not with the warm front.
See, and Oklahoma's right in there.
Yep, so yours might be more of the cold front.
So more of a occluded front?
Kind of this
Well, because
one.
it's warm already, and when cold air mixes with that warm air from probably the polar jet stream, that's probably when we get our tornadoes. And I think because
We'll
we're
be
on
talking
that
more
border,
about that in Unit 4.
I feel like because we're more along that border, we get it worse.
Yeah. Anytime you have a cold front, remember how it's like a steam shovel, and like you were saying, the warm air just lifts straight up, and that creates a possibility of really unstable air. So yeah.
Okay.
And unstable air gives you your tornadoes. So then over here on the right is where I have you see that one. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's 6 here. I guess 6 would be where it's dissipating. But this is kind of showing you the 6 steps of, this says front develops, wave develops, cyclonic, clockwise or counterclockwise rotation, I think it says, mature stage, I don't know what that says, diminish, and then this says it's done. Then the next one, so these
I like this one probably the best.
good. These last two kind of go together. I think this is cool. I think in weather, I think it's neat to think of what's happening up here affects us down here. And so this is kind of a couple questions kind of along those lines. First off, remember that, like you said, this is the jet stream, the dark purple up here. And so we call this a ridge associated with high. We call this a trough. It's associated with a low. So there's that going on. And then at the surface, we said for a high, basically a high, you have air going away, and it's going to convert to a low. So in order to sustain it, it has to have air coming down, and that's kind of what this is showing you. And for a low, it's going to have air coming in, and it would build up to a high. So to get rid of that material, it's going to go up. So the surface works with the upper elevations. I think that's neat too. And I think that's it. So, what do you think?
Makes sense.